Welcome to this episode of Eureka. We are with us Professor Alok Dhawan, Director of Indian Institute of Toxicology Research, Lucknow, which is a constituent unit of CSIR. When you eat food, there are quite a lot of food color. Do you know, are they safe? How much is safe? When you drink water from a plastic bottle, is it safe? The Indian Institute of Toxicology Research ensures this safety by instituting policy and safety standards. We'll take a quick look at the brief profile of Professor Alok Dhawan and then we'll continue the conversation.
Professor Alok Dhawan is working on various aspects of toxicology. His area of research is alternate to animal models toxicology, genetic, nanomaterial and in silico toxicology. Professor Dhawan has completed his PhD in biochemistry from Lucknow University with specialization in brain metabolism. He has received various eminent awards for his outstanding work. Noted among them are Vigyan Ratna from Council of Science and Technology, Gold Medal from Society of Toxicology and CSIR Young Scientist Award in 1999. Professor Dhawan has held various key positions in scientific fraternity and has also authored over 130 international journals.
Thank you for sparing your time. And this institute, which is almost more than 50 years now, established in 1965,
That's right.
has been tirelessly working and promoting toxicology research into a world-class institute in India. Let me start with a question. See, when the institute was started, we had mining as a very major industry.
Sure.
India was just to become an independent country, and then we needed quite a lot of natural resources. So iron ores, maybe magnesium ores, maybe various things we were mining, and industrial pollution and occupational hazard was a major concern. And your institute started with that as a main focus.
Sure.
But times have changed. Has your institute changed?
Yeah, so I think it's a very pertinent question, and I think as you very rightly said, when the institute was formed, the name then was Industrial Toxicology Research Center, which itself indicated the vision and mission of that institute at that point in time. And as the nation's demands have changed, and so have we, and as you rightly mentioned again, at that time there was a lot of industrialization, so a lot of work went into how the people working in the mines, it could be iron ore, it could be manganese, it could be asbestos exposure, etc. We were looking in those areas. Not that we have stopped looking at that, but I think we have now come to a point where we understand what happens, and the mines, etc., have got standards where they are now providing adequate, protection to their workers. And as we moved, we started understanding if they are exposed, what is the mechanism by which these things are happening, and so that came into more mechanistic aspects over the period of time. And now, as of today, we are having 5 very contemporary areas in which the research is focused. One of them is the nanomaterial toxicology.
Nanomaterial toxicology?
The other is regulatory toxicology, which is a vertical which supports the not only the industry but also the policymakers.
Okay.
The third is food, chemical and drug toxicology, like you rightly mentioned. We look at all the food additives, colors, contaminants, adulterants and so forth. And then the fourth is systems toxicology and human health. And the fifth is environmental toxicology. So what we always say that we look at air, water, soil, the entire ecosystem is our forte, and that's how we look at it. We don't look at it as separate, let's say human and animals and plants and water, but we look at it as a holistic ecosystem and how each one of these are interconnected, and if one is polluted, what is the impact on the other. So I think that's how we have moved from industrial toxicology as a small center to a world-class institute now, where we actually are at the forefront of these areas that I'm talking to you about.
Interesting. Let me go back to the past a bit.
Sure.
Just to understand the institute's contribution to the nation building. When the mining and industrialization was a major thing, when the name was itself Industrial Toxicology Research Center, what do you think were its major achievements?
So let's say in the area of leather, or in the area of manganese mining, or in the area of asbestos mining, our epidemiology section and the other people, along with them, scientists would go there, doctors would go there, and they would examine these people who were involved in these mining, and would come up with what are the adverse effects or adverse impact of these miners when they're working in such and such industry. And that's how we started building a rapport with the industry at that point in time, and the mining industry would come to us. And slowly it became a norm, which the government also accepted, that one of our epidemiologists would go and visit on a regular basis these industries and give them the inputs from the scientific perspective as to how they can protect their miners from these ill effects. And I think over a period of time, the awareness that came about was tremendous. And now we see that these miners are given all kind of protective gears that they can and also the timings were reduced. So if you're working there for a certain amount of time and the exposure is beyond a certain extent, then you'll be moved to another area. So that was, I think, the miners' health was the major issue, which our institute, based on the scientific inputs, was able to provide to the industry.
You were past student of the very same institute which you are heading today.
That is right. That's right. So I did
For
my
that, of course,
PhD.
I should congratulate you on behalf
you.
of all our viewers and then
Thank
the country. Can you tell us about your student life? I mean, what was your work that you did in this institute as PhD student?
Yeah, so as a PhD student, one thing I must say to my young audience who is listening now, I think we get very impatient when we join a PhD and we immediately want, when is my first paper going to come, and, how soon, within 3 years, should I get my PhD in 3 years' time or 4 years' time? That's the first question even before they join. I think what they need to do, and they probably don't realize, is that they should sort of coin the question after understanding the area. And what I keep saying, I will repeat it here for the benefit of the audience, both parents and the students. Guides and supervisors are to guide them, to supervise them. End of the day, if they do not learn themselves how to frame questions and how to resolve them and how to come up with hypotheses, end of the day, they will turn out to be good technicians, not good scientists.
Yeah.
So I think I was blessed to have people around me who gave me that opportunity and freedom to operate. So when I started with looking at what are the harmful effects of plastics, for example. I spent about a year and a half looking at, how would we test a plastic, what goes around doing,
This was around which year? Like
It's about 86 that I joined.
It's about the mid-80s that you are
That
doing
is
your
right.
PhD, and then you looked at the toxic effect of plastics.
plastics,
I mean,
right.
that's the kind of time
That's
when
how
plastics were becoming profused in India.
Absolutely.
Right? Yeah.
And but then very soon I realized that there's another area which is coming up in a big way, and that was to do with neurotoxicity. And so we looked at chemicals that pass the blood-brain barrier and how they reach the brain, and how would they impact the brain. And unlike the liver, the brain is a very sort of heterogeneous organ.
Okay.
And the one thing, again, I just for the benefit of viewers, I should tell you that this part of the brain, which is the olfactory bulb, they are directly connected to your nose. And so the barrier is not as profound as you have throughout the brain.
Okay.
And that's where all the drugs go through, this. So that was very exciting, and that time not much was known about the metabolism taking place in the brain. So I then spent almost another 3.5-4 years working for my PhD in that area, and that was very, very exciting. And one thing, again, through this program, I must say, at that point in time, we asked tough questions.
Okay.
It would take time to do it, but we asked tough questions, and I think that is how that bar of excellence was raised over a period of time.
So the point is that take tough questions, ask tough questions, take that challenge. That's an important point that is being made.
Sure.
We'll take a very short break.
Sure.
We'll continue this conversation. Welcome to this episode of Eureka, and we are having a very interesting conversation with Professor Alok Dhawan, Director of Indian Institute for Toxicology Research, Lucknow. Thank you. Before the break, you were mentioning that the barrier between our nose and the brain is not that strong. So something that we can smell can go into our brain, which also means the air pollution, if there are toxic material, it can also affect the brain. Is that right?
That is absolutely true. And in fact, a very recent study has come out that shows that people in the UK, they have studied the brains, human brains, from people who were born, brought up in Mexico City, and people who were born, brought up in the UK.
Yeah.
And they took postmortem brains and they actually sliced them and looked at what was happening. And they found a lot of nanoparticles, magnetic nanoparticles of iron inside the brain of people who were born, brought up in Mexico City, as opposed to what they found in people who were born, brought up in the UK. So I think that's a very important thing, a very important finding that they came up with. And
so in some sense, figuratively, one can say that what you smell goes into your brain. In some sense,
absolutely, absolutely it does. Absolutely, and that's how olfaction works all the time. So there are a lot of, I would say, nervous transmission, or the transmission of the molecules that takes place, but also part of it actually goes into your brain. And
yeah, before the break, we were actually discussing about your PhD work.
That is right.
That's a time when plastic was being profusely used in India, and then you were trying to look at how plastic pollution can perhaps affect human body. Can you elaborate on that? I mean, we just drifted.
Yeah, so I think two things that I did for my PhD in that time. One was looking at various methods of how to test plastics and how to come up with methods that would provide you adequate, testing or adequate quality control of the plastics that are being used. And the other component was that because, as I mentioned, that the institute is in the forefront of different contemporary areas at that time. So that time agriculture again was in a big boom. So we were also looking at pesticides, and that was the other area that we took up as pesticides. And I did mention that we looked at 3-4 areas at the time, and then we look at which one is more productive or which is the best one. So I took up the brain metabolism as my full-fledged PhD program. And we looked at pesticides and carcinogens, how they enter the brain and how they get metabolized, and what are the harmful effects that they cause to the body at that time. And we were using animal models to simulate.
After your PhD, apparently you had a small stint in abroad.
Sure.
Which kind of opened up a new area of looking at something called comet DNA or something.
Sure. So I think so that actually one thing for the viewers, I think it's more to do with how the students should take up challenges. And at that point now, I must say, because I was a master's in organic chemistry, and so that gave me this edge that we could understand the biochemistry or what is happening inside the body much more, I would say, much better than a average student of, let's say, other fields. But that also gave me that added advantage of taking up challenges, and that probably came through my genes, if I may use that word. And why I'm saying is that at that point in time, around 93, I got the INSA Young Scientist Prize. And as part of that prize, and I must compliment the government for thinking of those schemes, that the INSA used to send, still does, the INSA Young Scientist awardees could choose a lab of their choice anywhere in the world, and they can go and actually work there for 3 months. And I think that was a game changer for me, because at that time the institute wanted that we could set up some more molecular genetic toxicology parameters or molecular epidemiology parameters in the institute.
So, which means that going to something like DNA and
that is right.
That kind of a work.
Yeah. I mean, rather than the body as a whole, we look at what happens at the cellular level.
At the cellular level.
That is absolutely correct. So therefore, I went to UK for a 3-month stint, and that's where I learned this new technique that was coming up at that time, which was called the COMET assay, where you look at the DNA damage in a single cell. And then I came back and established it in our institute. And I would say from that point onwards, my entire work was and still is around the DNA damage and repair pathways.
And apparently this work which you brought back, I mean the skill that you brought back, this knowledge that you brought back and then instituted within your institute is helpful even for people who are actually filling petrol in petrol pump and cycle rickshaw pullers.
Sure. So I mean, so what we are able to do, that we could look at very micro events that are happening inside the body, and so therefore, as I said, it was more to do with molecular epidemiology, and so we looked at various groups of people whom we could assess. So we could also look, and that also led to
with the petrol pump fillers. What was the exactly thing?
Yeah, so petrol pump workers, if you look at, these are people who get exposed to almost 7 to 8 hours.
Of the petrol fumes.
And what we are looking at is that whether these petrol fumes actually cause any damage.
Okay.
So we did a very systematic study measuring the petrol, these fumes or like benzene, xylene, toluene in the air where they were standing at that point in time, looking at their levels in the blood, and then going down to cellular level and seeing what is the impact of the benzene in the DNA damage. So I think that was a very systematic study.
This work has also contributed to establishing certain norms
Absolutely.
of how the people in the petrol pumps should
Yeah,
be
so
working,
that
right?
that we were always discussing with the owners of the petrol pumps what they can do to sort of mitigate this
Okay.
or alleviate the problems of the workers. And I think lot of them in the local area and in Lucknow area, they've actually gone ahead and practiced those things. And I must say that over the period of time we established this assay, we went ahead and did a lot of the new models for this. For example, we are now measuring it in plants, in bacteria, in other organs. And in 1999, the person with whom I had started this work, the both of us actually edited a book for the Royal Society of Chemistry on the comet assay itself. The entire book is dedicated to a technique.
It's interesting. We will continue the conversation, but we need to take a very short break. Don't go away. After the break, we are going to discuss very interesting things. In today's era, everybody is talking about nanotechnology. Is it a threat in some sense? Do we need to worry about it? We'll discuss it after the break. Don't go away. Welcome back to this episode of Eureka, and we are having a very wonderful conversation with Professor Alok Dhawan, Director of Indian Institute for Toxicology Research, Lucknow. Before the break, we were discussing with him about his work on using comet assay, a modern technique to assess DNA damage at a cellular level because of environmental pollution. And he was discussing about how in a very simple system like even petrol filling station, the workers could be affected. It was a very interesting point that you made. But then let's move to the recent times, I mean modern times or the future.
Sure.
Just like plastics came into the picture in a big way, I think nanotechnology, electronics, these are all coming into our life in a major way. I mean, cell phones, for example, is abound in India. I mean, it's all there, almost there. Do you think they all have an impact? And then do we need to be worried about it? And is your institute sleepless about it?
Yeah, so I think it's a very, very important question that you asked. Nanotechnology, I think, is something that is going to affect all of us for a simple reason that it's getting into all other technologies. Unlike, let's say, the green revolution or pink revolution or white revolution or BT revolution or IT revolution, they were restricted to an area.
They were all sectors. They were all silos.
Yeah, but this nanotechnology has gone into all silos, and so it's kind of an overarching technology that's going to affect big time. And I think that not only our institute, which started almost in 2005, we started nanotoxicology, looking at the adverse effects of nanomaterials way back in 2005. And I think it was, again, we're the first to do that in this country. And since then, we've been looking at various commercially, I would say, important materials that are there in terms of nano. So it could be zinc oxide or titanium dioxide, which is used in sunscreens and so forth. And to other more complicated nanomaterials that could be used for drug delivery, for example. And in fact, a lot of our data that has been produced has not only gone into setting standards internationally, but also has been very important in the area of policy making for this country. We also came out with a policy document on the safety handling or safe handling of these nanomaterials in the laboratory, and that again is a published document based on which the government of India has taken.
Yeah, I mean, you made a very interesting and important point in your presentation just now. I mean, most people don't think nanotechnology is there in our life now.
Yeah,
they think it's some futuristic.
No.
Every sunscreen, almost every sunscreen that people use today is having nanomaterials. Is that right?
So I would say majority of them, they are labeling now. I think most of them, if they are putting nanomaterials, they are labeling it. But in the world, there are several big companies that are manufacturing nanomaterials. And why only sunscreens, even shirts, the textiles we wear have nanomaterials on them. Your composites in the aircraft have nanomaterials in them. And so you name it, and the paints have nanomaterials in them now. And so I think it's very interesting.
Now also I mean, if you look at another aspect of our life, our lifestyle is changing.
Yes.
Like if we had spent, quite a bit of our wake up time outside. Today, even the wake up time, we are spending in enclosures, office spaces or other spaces. We were worried about, at one point of time, our environment, I mean the outside world, which is of course an important thing. Do you think sitting inside a room, spending 8 hours of working hours and then going back to your house, again spending almost, in some sense, except for traveling, I think 24 hours we are inside some enclosures.
Sure.
Does this environment have an impact on our life, and what do you look at it?
Yes, I think it's again a very interesting thought which you have put forth, and I think people should understand. I mean, our childhood was mostly outside, outdoors, so and therefore majority of the standards and majority of the monitoring was done outdoor. And most of your viewers would know outdoor air pollution, and that's how it was called. But I think the new norm is indoor air pollution. We also now have to look at what is the levels of certain gases or certain particulate matter within, or certain allergens within the home. So now if you look at the lifestyle, I think you very rightly pointed out, right from our workplace to the way we travel, maybe in trains or in aircraft, it's all sealed environments that we go into. Our cars are now mostly air conditioned. So from one silo to the other, we move in a closed environment. I think that's a very important thing that is coming up, and we started again way back looking at the internal or the indoor air pollution, and I'm very happy to inform the audience that we now have standards. We now monitor the indoor air quality as well, and so that quality of air should be good. And now, because of the fact that, as you would know, that we are a CSIR institute, and our president is the Honorable Prime Minister, and there is always now a thrust that we should come up with technologies that can help the common man. And with that in mind, we are now putting forth some technologies along with our other institutes, which can sort of mitigate this indoor air pollution, or can take care of the indoor air pollution based on our research and based on the research of other CSIR institutes. So I think that's a very important area that we, moving forth, as you said very rightly, that from now on, I think the future lies indoor.
So that also
people
has
have started
been,
working from home, for example. I mean, so they don't even go to work; they work from home. So they are almost spending their entire life within air-conditioned rooms. I think we need to understand this much better and how it impacts our lives.
Another question that, not actually a question, a comment that I would like to seek from you. Your father was also an illustrious director of a CSIR Institute, Center for Drug Research Institute in India. Was he a role model for you?
Yeah, in some sense, I would say not only a role model, but I think a good mentor, I would say. And when I go to my school, or when I sort of engage with students, which I do very often now, I always say, let them ask questions, right? And I think that freedom I had in asking questions to him or to my teachers in those days in school, which I don't see now. I mean, if you ask a question, you are immediately bogged down and say, no, this is a stupid question. And I always say the questions is never incorrect. The answer may be correct or incorrect. So I think we should encourage students to ask questions. I think that is where their sort of innovation lies. That is where the creativity lies in the students. So I think that is what I got at home.
So coming back to your institute and the contribution, I mean, I'm told that your institute is developing a water purifier, which perhaps can have a very major impact on India.
Sure. So I think as you know, there are a lot of purifiers for home segment, and flooded market is flooded. But I think what we are targeting along with other institutes of CSIR is to come up with a end-to-end solution for water purification. And at the end, we'd also like to have a water purifier for community basis.
So which means that, for example, in a school or a big office,
hospitals, hostels, school hostels, which are residential schools, and they can get pure, clean drinking water at very low cost.
Okay.
I think, and the other thing we are trying to see is how to put these water purifiers even in villages, and so therefore it should be solar powered. And the maintenance should be, as minimum as possible. So if it's a
and also it should provide you a large amount of water rather than
absolutely. So what we are currently targeting is close to about 500 liters per hour, somewhere close to that.
500 liters per hour.
And that is also modular, so we can add more such units to produce a larger volume. So if the municipal people also want that kind of system, we can have a structure that can be multiples of these, and we can provide much higher water quality. The other thing we are focusing in terms of our expertise is to come up with a mobile laboratory in a sense, which will look at environment and human health.
What would be your message to our young audience?
So I would say from the background that I come, you should eat safe, drink safe, and have safe air to breathe, and that will only come from when you or how you conduct yourself in the society. I think we have to become very, very sort of important players apart from the government. Government can only form policies, but at the end of the day, we have to engage ourselves in ensuring that the environment is safe for us to live. And also we provide a better environment for our future generations. I think that's how it is.
Yeah. Thank you. Thank you for being with us in the show. And we should say, many people may not know about the Institute or toxicology research, but in a very unseen way, through a policy instrument, your institute has been playing a very important role in ensuring slave life for people in India.
Sure.
Thank you for being in the show, and then it was a very wonderful conversation.
Thanks very
for
much
being
indeed.
here.
Thanks for having me. Thank you.